Hey guys, in the previous video we went through the steps on finding the chemical formula for simple compounds. And just to go through them again, the first step was name the compound, the second step was write the chemical symbols of the elements, step 3 was to find the combining powers of the elements, and then step 4 was to simplify the ratio and then to cross multiply. Well, today we're going to be going through something different, something called radicals. And radicals are basically common arrangements of elements found in nature that play a role in our chemical formulas. So they're normally found all together, and they have a specific combining power. So the ones you need to learn are the ones on this table, and there's no way around this, guys. You actually have to learn all of these off by heart. You have to learn their name, their symbol, and their combining power. And just take a special just take a note of this ammonium one, because this is the only one in the entire table that has a positive combining power. So all of these will have negative combining powers, meaning that they want to gain electrons. Ammonium is the only one with a positive combining power. Okay, let's go straight into an example just so I can show you how we're going to be using this table in order to do examples. Okay, so the first example we're going to do is we are going to find the formula for ammonium phosphate. So going back to our steps, step 1 is that we write the name of the compound, which is ammonium and phosphate. Step 2 is we write down the symbols. Okay, so in the past you would have used our periodic table, but not today. Today we're going to be using our table of radicals. Okay, so we look for ammonium. Okay, as I said, it's the important one that we have to learn, the one with the positive combining power. So ammonium. We write it down, and then we also go find phosphate, which is PO4, which has a combining power of 3. So now the next step is we write the combining powers. Okay, so as I said, 1, 3. We don't need the signs. The signs are not important. If they're giving you an element, it means that it should be fully balanced, guys. So we don't need to put the signs in at all. So now we need to see if we need to simplify the ratios. 1 and 3 can't simplify that ratio anymore, so we go straight to step 4. We write down the names again, cross multiply, so we know the chemical formula for ammonium phosphate is NH4 in brackets 3 PO4 is the formula, guys. Okay, the next one we're going to be doing is one where we're actually going to be using both our periodic table and our table of radicals. Okay, so the next one we're going to be doing is we're going to find the formula for aluminium carbonate, and you guys can tell if you watched the previous video, I do like aluminium because it can be both lose electrons or gain electrons, but in both these cases they are going to be losing electrons. Okay, so first 2 steps, write down aluminium and carbonate. We write down, as I said, as Al, and then we know from our new table that I've showed you here that carbonate is CO3. Okay, next step is going to go find the combining power. So let's start with aluminium because we've already done these before. As I said, it's in group 3 of our periodic table. So it's either going to gain 5 electrons or it's going to lose 3 electrons. So we know that the combining power of aluminium is 3. And then carbonate, it's over here on our table, which has a combining power of 2. So we just write that down straight away. Again, this ratio can't be simplified any further. 3 and 2 can't be simplified any further without involving fractions or getting bigger numbers. So we go straight to our next step, which is the cross multiplying. So we're going to take the 2 to aluminium and the 3 to carbonate. So then our formula for aluminium carbonate is Al2 CO3 in brackets 3. And this is the formula for aluminium carbonate.